Hello friends, welcome back. Now the question which we solved using the method of joins, now I'm going to try and solve the same question using method of sections. Method of sections is method of sections. Basically this method is used when we have to find the load in middle of a truss. So in this case, this is a perfect example of that. I wanted to find the load in member CH. I don't want it to find the load in this member and this member or this member or this member. If you might have watched my previous video, you might have seen that I had to find the load by using the method of joins. I had to find the load in this member, this member, this member, and this member. Then I finally end up reaching to CH. So in this case, we can avoid all those laborious works, and then we can directly find the load in member CH. Let's see how. So one thing you have to do, the member in which you are trying to find the load, you have to cut that section, and you have to cut the whole truss in such a way that this member CH you also cut the member CH in that. So, and you try to cut as many as members as you can. So A, you wanted to cut the member for which you wanted to find the load, and second, you wanted to cut as many as member as you can. That's how you select your cross section. So this, I'll cut it from here, and I'll cut it from here. So I've been able to cut 3 members. So let's draw the free body diagram. Now I can select this portion, I can select this portion, or I can select this portion also. It depends upon your choice. Both will give you the same answer. So I'm gonna select the right half of the section. So this is the diagram. So if I draw the free body diagram, and this is how the free body diagram will look like if I join these points. This is C, this is point B, this is point H, and this is point A. And in my previous question, we've already figured out the load. This is 12.5. So I'm not gonna do this again. The reaction load, if someone wants to understand how we figured out the reaction load, they can watch my previous video where I use the method of joins. Reaction load comes up to be 12.5 kips. Now I in this question, in the method of joints, we use the sigma f of x equal to 0 or sigma f of y equal to 0. These are the basically two equations which we used. Now we will use the moment equation. So I will take the moment about point B or the point H, depending upon the requirement of the question. So let's start with taking the moment about point B, because I wanted to find the load in member CH. That's what I wanted to do. And so I'll take the moment about point B. If I end up taking the moment about this point, this is H, this is not H, this is G. So if I end up taking the moment about H, then I won't be able to find the load in this member, because CH has no perpendicular distance from H. CH is passing through the point H, so I won't be able to find the CH. So that's why I end up taking the moment about point B. So if I take the moment about point B, then I have to before even start taking the moment, I will take the components of CH. So let me change the color. So this will be the component X component, this will be the Y component of CH. So if this value is this, okay, let me draw here. If this value, I'll zoom it in. If this value is 17.3 and this value is 10, this is 20, and this 20 is given to me. This 10 I can divide. If I divide this in 2 halves, this figure is not accurate, but this value will come out to be 10, and this value comes out to be 10 also. So that's why I put this value as 10. And then this is 17.3. If this is 10, this is 20, this is 17.3. That's how I end up writing 17.3 here also, because all these sections are symmetrical. They all are symmetrical. Now let's write down the value of CHX, which is equal to CH times 10 over 20, and CHY is equal to CH times 17.3 over 20. And now let's write down the equation about point B. So if I write the equation about point B, So this will be A is trying to rotate it in clockwise direction. Anything clockwise we take it as negative. So 20, not 20. So 12.5 times 10, perpendicular distance is 10, and this is negative, plus CHX, and CHX times this is CHX, this times 17.3, and plus this is trying to rotate in counterclockwise, so positive, CHY times distance, perpendicular distance is 10. So this distance here is 10. So this is CHY, and then minus, is there any other? Yeah, HG also. Then this is plus HG, because HG is also trying to rotate in counterclockwise direction. HG times 17.3. That will be the value equal to 0. And I'm gonna feed, this is negative 125, and CH value I can feed it as 0.5 CH times 17.3 plus 10, the CHY is 0.865 CH. If I divide these two values, that's going to give me 0.865. So CH times 10 plus HG is in the horizontal direction, so there is no component which I need to take, equal to 0. So now, so this is the 125 goes on the other side of the equation, becomes positive 125, and I can collect these two. So this is 17.5 times 0.5, which is 8.75. Wait a sec, so I can first, yeah, 17.3 times 0.5 is 8.65 plus this is also 8.65. This is CH plus 17.3 HG, and then I add these two values. This is gonna give me times 2 17.3 CH plus 17.3 HG equal to 125. This is a really beautiful equation. So I can say CH plus HG equal to 125 divided by 17.3. So 125 divided by 17.3 will give me 7.23. It is 225, but I'm going to round this value to 7.23. So I'm going to get stuck here because I don't know value of CH and I don't know the value of HG. So now what can I do? So here the most important concept of the method of sections comes into the picture. If somehow I can find the value of HG, oops, what happened here? So if somehow I can find the value of HG, I will be able to solve for the CH. So if I look into this diagram back here again, how can I find the value of HG? So I'm gonna erase everything here. Oops, I am gonna redraw it so that there is not much of a hodgepodge. So insert, draw. So this is like this. This is CH. And now I'm gonna, if I draw a dotted line, and this point is C. So yes, in this I've cut it from this point, okay, before the point C. If I start taking, if I'm taking the section left of the point C, so this is the section which I have considered. So in this section, although I haven't taken the point C, but I still can assume point C while solving the question. What do I mean by that? Is that I can assume that this is a point about which this whole truss will rotate, whole cross section will rotate. So I can take this point also. I can join these 2 points and can say that I'm going to rotate this body about point C, and if I rotate this body about point C, what will happen is I can easily find HG, because that will cancel HC and BC out of here. And one of the things which I haven't considered, so luckily it didn't create any problem for me also, so I didn't consider this load here. If I draw, I forgot to consider this point 6 skips when I was solving for point B. So because I was solving for point B, this load was acting on point B, so it didn't affect my equation here. Now I will take the moment about point C. If I take the moment about point C, so let's take the moment about point C. Sigma MC equal to 0. So this 6 skips 6 times the perpendicular distance from the C will be, this will be, let's see it here. So this distance from here is 20. This distance is 20, and this one will have a distance of, from point C will have a distance of 30. So point A has a distance from point C of 30. So 6 times 20, it is trying to rotate it in counterclockwise direction, so positive. So then minus 12.5 times 30 will be the value for A when I take the moment about point C for the reaction load A. Now, is there any other load? Then I have HG also. So plus, this is trying to rotate in counterclockwise direction, plus HG times 17.3 equal to 0. That's how we will write down our equation. Is there anything else which I'm missing? No. Seems like I've considered everything. I won't consider CH because the line of the action, it is passing through point C, so there is no perpendicular distance. So the same line of action. And then I can't consider this value also because again it is passing through this, the line of action is still the same for BC. So again this will be this BC won't have any perpendicular distance from point C. So this is 6 times 20, this is 120, and this is 125, 450 I guess. Yeah, 450. I'll still do the calculation, I don't want to make a mistake. This is not 450, this is 375. So good thing I've done the calculation. 17.3 Hg equal to 2, and then 375 minus 120 will give me 225, negative 225 plus 17.3 Hg, and this goes on the other side, becomes positive. Hg value will come out to be 255, not 225, 255. So I'm rushing and making mistakes. Divided by 17.3 divided by 17.3, which comes out to be, Hg comes out to be 14.73. So did I consider all the negatives and positives? Yeah, that's fine. So what I'm gonna, what happened? So I'm gonna, I need to expand this, zoom it in. Awesome. Seems like it stopped working. So yeah, slowly but surely it's working. So I'm gonna use this equation, I'm gonna write it on this side. My computer is really slow. So CH, oh no. Yeah. So CH plus 14.73, this is a positive value, equal to 7.23. And then when I take this value on the other side of the equation, so CH value will come out to be 7.23 minus 14.73, and CH value will come out to be minus 7.23 14.73 minus 7.23, 7.5. This is negative 7.5. So kips, and negative means CH is under the compressive load. This is compressive kips. So that hopefully you were able to understand the method of sections from this example. I'll see you with another question.